Well, welcome, folks. I think we'll go ahead and get started. For those of you who don't know me, my name is Erik Albrecht. I'm with HDR here in our Louisville office. I want to welcome everybody to the structures room for this virtual partnering conference. See a lot of familiar folks on the attendee list, so welcome everybody. Want to go ahead and introduce JC and Clayton from KYTC Business Structural Design, the Geotech branch. They're going to talk to us a little bit about Geotextile Fabric. Also want to thank you both for taking the time to prepare your presentation and put this together. So take it away.
All right. Thank you, Erica. All right. Let's see if I can get this going.
I'll step off here too, JC.
Oh, okay. All right. Is that popping up, Clayton? Or thumbs up? Okay. Like Erica was saying, my name is JC Wilhoite. I work for the Kentucky Transportation Cabinet. I am part of the Geotechnical branch, and I am the supervisor over the soil survey and test section. Basically, I am in charge of most of the roadway reports, if you all are involved with that at all, and also a lot of the lab testing. I work with that. First thing, though, I wanted to do was I was wanting to kick out a poll. So if you all can attend, and there's a reason I'm asking this, if you all can go ahead and answer that. So we have a few responses. I'm actually learning to do this myself. We started school a couple days ago. So while I'm not very qualified, I am trying to learn how to be a homeschool teacher, and this is great. So if something crazy happens, that's just a little background of what's going to happen. If you hear a dog barking or a little girl screaming, that's my daughter. So it looks like most people don't have that excuse. But anyway, the subject matter for today, we're going to be talking about the cement versus lime stabilization, and we have a site study. I've kind of cleansed this a little bit. It's an ongoing project, and there's still a lot of people involved that are active. The purpose behind this is not to really throw anybody on the bus or try to cast anybody in a good light. Really, it's just kind of a lessons learned and what we want to do moving forward. So with that, let's get this kicked off. Let's see. Just a little background on this project. This is a design build project, and at KYTC, we're kind of new to design build. It's been going on for a little while, but we're still learning a few of the nuances of it. But since it is kind of a newer thing that we're trying to do, we really wanted to stress that we wanted to minimize change orders for this project. Something that's different from a lot of design build type projects is we provided some design criteria prior to any of the sampling and testing and prior to the bidding process. Like I was saying, the bids were based on this design criteria. So since we didn't have a lot of information to go on, we had to do a little bit of guesswork, and that kind of led to this whole presentation. And one other background is this project is located in northern Kentucky, which will kind of give you an idea, if you're used to working in that area, what kind of, what we should be expecting as far as the soils go, the geology, that stuff. So the design assumptions that were sent out in the bid package was that we will be using some sort of stabilization for the subgrade. Pretty much all projects now moving forward, we're going to try to do something. Historically, we may not have. We could have went more with the soil subgrade, but one way or another, we're going to try to use something, either a mechanical stabilization or a chemical. So we threw out there that the CBR of 3 would be used for your pavement design. Maybe a little high for northern Kentucky, but it's viable. Durable rock will not be available, which is a good assumption. Everything out there is pretty much going to be a non-durable shell when you actually get to bedrock. And the chemical stabilization will be used, and it was specified that cement will be the chemical that is used for stabilizing, and that is based on a 6% weight. Okay, so now that was out there, we threw that out there for the bidders. They put their packages together. It came with the whole design team for the highway design, the geotechnical engineering, and the contractor all in teams. They started to submit their plan back to us, and that included and this is the geotechnical part, and it only included in this slide is just for the roadway testing, the profile testing, not including all the structures. So there were over 60. I'm going to check, and I right in the middle of this too. If you all do have a question or anything, just go ahead and throw it out there, and I'll try to answer it as we go. If you do have a question. So there were 60 borings specified. Of that, we got from those 60 borings, we got 53 bulk samples. Now that's kind of a high ratio for typical, but the spacing on the borings was a little higher than what we usually do. So that's really pretty much why we had such a high ratio of samples to boring locations. And it's fairly standard. The testing included soil classification, moisture density or Proctor testing, and CBR testing. So everything so far is going pretty normal. And some of the results from that, if you're not too much into the geotechnical area or the soil testing part, this may not mean a lot, but really moving forward, if you're going to design or use this for pavement design, I'm just going to try to go over these real quick. So using chemical, it'll kind of start to sway you one way or the other. So we had 53 samples, and of those, one was a sand. Everything else was a clay. Mostly moderate to low plasticity clays, or CL, if that's what you're used to seeing, and 15 high plasticity clays, or CHs. The whole of all the tests, the plasticity index, which is the difference between the liquid limit, plastic limit. You don't necessarily need to know that if you just want to look at it and just see what the number is, just to know. But the range of that went from 46 to 12. Now, if you're familiar at all with how we like to stabilize or use chemical stabilization, you'll know that that's going to start swaying us one way or the other. And then the percent fines, that is silt and clay sized particles, everything smaller than a number 200 sieve. That ranged with a minimum percent passing of about 41%, and a maximum of about 95%. The reason that is important when we're talking of chemical stabilization is we have criteria. The criteria that we provide in our manual, our updated manual, it basically we break it down into use cement or use lime. If you see if the PI is greater than 15%, fines is less than 35%, we like to use lime. On the other side of it, if it's less than 35% fines or less than 25 on the PI, we can use cement. Now you'll see that there is a little bit of an overlap in the PI. It's kind of a gray area between lime and cement as far as the PI goes. That's where if you get the lab results back, you can start to kind of put them in different categories. And here, I also wanted to show, this is a little bit more on the national level. We don't necessarily use this, but I did want to show that the FHWA, when they start to categorize what is the proper treatment, they look at the, first and foremost, the percent passing, the number 200 sieve, that's the metric equivalent, and they break it down. If you'll notice, all of our samples had more than 25% passing, so we're already automatically on the left side of this chart. And then they start breaking it down by the plasticity index, the PIs, and you can see that in our range, we didn't have any in the far left. The PI is less than or equal to 10. Several were between 10 and 20, and then several were greater than 20. Looking down, you can see that the cement for stabilization, we're looking at not suitable if it's white, and if it's that hash, it's a doubtful. Lime, as opposed to it in the row below that, you can see that with the PIs 10 or greater, it is usually suitable. So we're starting to kind of get an idea of what the proper treatment would be. I kind of just made this chart, maybe make it a little easier. And this is based on the KYTC criteria. On the left, you can see based on PI, we had 2 that fell into the hard into the cement category. 16 fell hard into the lime category, and 35 were either or. However, if you look at the category based on percent fines, every one of our soil samples came back at a percent passing greater than 35. So we have a lot of small size particles. So we're starting to get skewed towards lime. So as you can see, just to sum all this up, the KYTC criteria, all but 2 were for lime. The FHWA criteria kind of back that up. Also, the consultant Geotech firm also had a recommendation of using lime for our chemical stabilized subgrade. However, the bid was based on cement. The contractor prepared the workforce based on cement, and their timeline is based on cement. Now, if you're not familiar with the differences between the two, lime does take a little bit longer to work. You have to mix it, come back the next day after you let it mellow, because it's actually a chemical reaction that's occurring, and then you remix it before you compact it. Whereas cement, you pretty much have to do it right then. You spread it, you mix it, and it has to be done because the cement's going to start setting up. So there's an extra day involved in labor and a remixing that is always involved in lime. So it may be a little bit faster, cheaper, however you want to look at it. So when we presented these results back and we're working with the design team, there was going to be a significant cost increase if we changed from cement to lime. So where did that lead us? Well, so now internally, they asked us to evaluate both types to see, is it even viable for this type of soil on this project? If so, we're going to try, and just because we've done this in the past, we've used 6%. We also upped it to 9% just to see how it would test out. And then we also tested lime to see what's the difference. Is it going to be a lot better? But that required us to obtain more bulk samples because the consultant had done this before. All their samples were gone. So now we had to obtain more bulk samples. In our lab, we prepared these specimens and then we performed strength testing. Now, I'll show you in the graphs following this. We kind of use 80 PSI as a compressive strength just as a baseline. It's not really specified that that's what it has to be. It's just something that we use for if the contractor requests to get on it in a shortened curing period. So that was just a baseline we threw out there, but it's not necessarily like a hard line. This is what it has to pass. So with that, the test results came back. We started with a 6% cement, and these were all being pulled out of the same bulk samples. So we ran 11 tests, and you can see that all 11 failed to meet an 80 PSI. Again, that's just a baseline that we were going across, but you could see the strengths weren't really getting up very well. Some of them around 50 PSI at the time of testing. And just a quick note, we used our resilient modulus compressive cylinder to form all these. So it's really kind of an apples to apples comparison. They were all compacted in the same way, and they're all basically coming out of the same bag. So there's the test results for 6% cement. We upped it to 9%, and you can see now we actually cut the 6% cement off after so many tests didn't meet. We figured there's no more point in testing. We did additional samples with the 9%. You can see out of the 16, most of them met 80 PSI. Some of them got quite a bit higher. A few of them were lower. Those were typically going to be the CH materials. They had some trouble gaining strength. And then finally, we had a 6% lime mix, and this was at 7 days curing, and all the tests met a pretty significant strength increase. The scales are different on these charts, but you can see all the tests met. So we had some pretty good success. And then all together, this is a chart. So you can see the 6% was significantly lower. The 9% was a little bit higher. We had a few outliers that were low, and it was but significantly improved over the 6% cement mix. And then the lime was, you're just looking at it from the samples, it was obviously quite a bit better. So the result of that, we had presented our data. The design team and KYTC, they elected to stay with cement, basically because the strength gain didn't justify the increase in cost. There was, like I said before, there was a cost increase, and we couldn't justify that change at the time, especially with, budgets as tight they are. We had already allocated the funds for it. So it's really difficult to make a change. But we did get some caveats in there with the cement was going to be increased, particularly in the fast track areas. I think we could pay for the KYTC agreed to pay for additional cement just to make sure that in some of these areas we were going to get the strength we needed. The contractor said they can mix twice if the soils appeared clayey. And so that would actually kind of help break down a lot of the problems with this, with using cement is, you'll see in a little bit, the difference between what's going on in the field and what we did in the lab, we actually were running those over a number 4 sieve. We were breaking the particles down pretty small. When you get out in the field, it's going to be a lot harder to do that because we're handling a very small amount and we can manipulate it by hand versus what you're going to do in the what we're going to do in the field. Sorry, I just saw a chat pop up. So if you all have ever seen the setup, and these are pretty fresh, this is from about a week ago. This is the cement is already laid out over the subgrade. The contractor is out there. That is a water truck getting pushed by the actual mixer. And so it's adding a little bit of water. There is some water that's required to get, obviously to get the reaction to start. And so if this is your first time seeing it, that's kind of the basic setup. And I have a video real quick just so you could see what it's like. I hope this works. So you see they let this go. Let's get back here. So you can see that that it actually, it can move pretty quick. That was actually without the water truck. That was actually a first pass over, and what they were going to do is not add water on the first pass, and then they did a remix to add the water at that point. The thing is, when you see this, and this is me taking a picture. I had some keys in there for scale, but you can kind of start to see that there are some larger clods. Sometimes the soil is not getting broken down, and what you can end up with, instead of a really homogeneous mix, you kind of end up with cement coated clods of clay, which is not really what you want. You want it to be mixed a little more thoroughly, but it's really difficult to get that because these soils are so cohesive. Let's see. This is a quick check we did. So we pushed a kind of a little tube sample, and you can see we put some, if you can see the coloring, it's phenolphthalein is just an acid we poured on it, and the dye actually kind of comes out purple when it comes in contact with the cement or lime. You can use it for either one. You can see we pushed it about 9 or 10 inches, and we were still detecting quite a bit all the way throughout. It's just a good quick check to make sure that we're getting our mixing depth and it's getting mixed fairly well. This is a in situ strength test we did real quick. It's just a DCP, or cone pentrometer, and you'll count the number of blows as you're going down through the subgrade, blows per inch, or whatever kind of metric you want to use. And then you can come back and test it, as time passes, a few days, to see as it's gaining strength, are you getting a good strength gain? And also we're testing this pretty quick. You can test several spots just to make sure that, it's getting somewhat similar test results. You don't want to have really strong spots and weak spots. And here we have, after they put, you can see there, after they compact the subgrade, they'll put a tack coat down, and then we come back in a few days after that, and we'll actually take a core of the subgrade. Again, we did the acid drip test. You can see that it was still a pretty good mix, and you can use those to get another strength test to make sure that we're getting the kind of strength that we're wanting to get out of the subgrade. So, like I said, these are pretty fresh. This is construction is ongoing, and the stabilization efforts began in the first week of September. So here we are. So these are pretty hot and fresh. We don't know how the end result is going to be, but again, from the lab testing, you kind of see, had we known early on which way to go, we may have went with lime as a better alternative, or if we could have negotiated a little bit better, that may have worked. It just was really difficult with the way this project was set up and where the funding was already secured to make changes that were that significant. But hopefully, if you all as pavement designers or as designers in general, trying to know what region you're working in, that may kind of give you a good idea of what kind of chemical stabilization you may want to use. And also, I know a lot of people kind of push towards cement. Sometimes lime can be a very good alternative, and you can see just from the strength test results, it does gain strength, especially if you're going to deal with really fine-grained materials and materials with a lot of cohesion. And with that, if you all have any questions, I don't know if you want to do it at the end too. I guess we can open it up, and if not, I guess Clayton can take over. I must have done a pretty good job. Does the KYTC spec use micro cracking? I am not familiar. I like the next comment better yet. Thank you, Jason. I don't know. I don't believe we spec out micro cracking. And I think Tony may be here if he knows about that. Like I said, Tony Beckham, he is kind of our resident expert on this, and he helped put this together, but he's maybe in the audience if he wants to chime in. If not, but James, I don't know. I'll have to look at that. I guess you can take over. And again, if you have any questions, I will do this again at the end. If you think of something, just whenever.
Cool. Thanks, JC. I'll switch over to the slides then if no one else has any more questions. Start at the beginning here. To start out, just kind of, we'll do another quick poll. If you all can see, well, I'll put up the poll here and I'll kind of discuss about it. Let's see here. So who's likely to interrupt your virtual meetings? As you can see back here, my daughter has a kitchen set back here and a few toys. She's 3 years old now. And so when we set up my initial desk here, I didn't completely plan for that. I can see a couple people have some dogs, cats. Let's see if the chat here. I could watch the video all day. I guess that's why I'm an engineer. There you go. Well, thank you very much. And I'll kind of get into talking about geotextile fabrics here. And so I'm going to be talking about our update of Section 843 for the 2019 spec revisions. So 843 deals with geotextile fabric. So I'm going to just kind of define a few things of what geotextile fabric is. So ASTM defines a geotextile fabric as a permeable geosynthetic comprised entirely of textiles. You can see the pictures I have there. I have two different types of geotextiles, the two main types that will generally be spec'd. So a non-woven, you can see there, they're more of a matte black, and they're not, the individual fibers aren't woven. And then you also have woven material. You can see they're a little more shiny, that picture. So generally, these are made of synthetic polymers. So in general, I'm just going to get into talking about the general requirements and general uses, just as an overview for geotextile fabrics. And so AASHTO put together a really good manual that helps with speccing geotextile fabrics. So the main general requirement is a strength/survivability requirement, so that when it's placed in the field, it doesn't wear or tear, and it's not going to break down in the field. First one, general requirements is to make sure it doesn't wear or tear down during placement and during use in the field. Also, it breaks down the fabric into different applications. So a drainage application. For instance, you can look at this middle picture here that has that French drain. So you can kind of see there it's used as a separator and a drainage application to allow that water to flow through the soil around the aggregate there, and then allow it to move through the aggregate and not allow the smaller particles to clog up the pores in between the aggregate there. It's also used for stabilization application, permanent erosion control. There's a picture I'm showing there that of the water with some riprap on top and then a fabric underneath. So that's showing the fabric there to help with keeping the soil underneath the riprap there. Permanent erosion control and temporary silt fence is the different applications that AASHTO M288 kind of defines. With our old 2012 spec, we kind of broke it down previously into different types of fabrics. And so each different type had a strength requirement. So different tests that kind of judged how it's going to survive when it's being placed. And it also had its application. So type 1 fabric was used for slope protection and channel lining. You can go down through there. Under drains, subgrader, embankment stabilization, embankment drainage blankets. And then also we had a type 5 for high strength geotextile fabric applications for when you're wanting to help with stabilizing a subgrade. In general, a few things that we wanted to try to clean up with the spec update is manufacturers that were making these products weren't making the products for a KYTC spec. They were making it for the AASHTO M288 specification. Being the fact that AASHTO is the national standard, and it's a little more uniform across the country for states as well as non-state applications. Another issue we had with the old spec was our type 2 and our type 3 were very similar KYTC materials. And also they were pretty low, and so they were susceptible to tearing and wear during placement. Also, there was some issues with getting manufacturers to supply a type 5 fabric that met our KYTC spec. Again, we had problems with manufacturers weren't producing a fabric to meet our specifications. They were producing it to AASHTO M288 and then seeing what of those they produced that met our spec. And in general, there seemed to be a little bit more types than necessary. So we're hoping to narrow down in general the type of fabrics that we specified. So these are kind of the goals we had for updating the spec, the 843 spec, to make it hopefully a little bit more uniform between us and the national standards for geotextile fabric. So the first objective we had was to align requirements to geotextile fabric to national standards that manufacturers are using. That's kind of included in that is that also that applies to whatever case we're using. We also wanted to reduce the number of geotextile fabrics in general applications. We had 5 types that were generally used, and we wanted to try to reduce that down. We also wanted to align our KYTC specific geotextile fabric jargon to the national jargon, which I'll kind of get into a little bit more in the next few slides. So our first goal with the spec update was align requirements for geotextile fabric to the national standard that manufacturers are using. So our quotation marks are pulled out of the new 2019 spec 843. So geotextile shall meet the physical and chemical requirements of AASHTO M288. As of the update, the most recent one was 2015. And so we basically just required the same side of requirements that were in AASHTO M288. With this update, AASHTO M288 for the survivability / strength requirements, they use the term class instead of the word type that we had used for our previous fabrics. And so from going forward from here, we're going to be using that same term class to help define what we mean when we're talking about a fabric. We also included in our updated spec that manufacturer or supplier must participate in the National Transportation Evaluation Program for geotextile geosynthetics. So current data must be posted in NetPet data mine. So what we're hoping there is that not to duplicate efforts at the national level for testing of geotextile fabrics and be able to reap the benefits of manufacturers submitting their products to those and getting tested. And so again, we're trying to align our objectives to the national objectives and also not duplicate other work. Next goal we had was to reduce the number of geotextile fabrics specified in general applications. So this is, again, just out of the spec here. 843.05 just talks about geotextile fabric for slope protection, channel lining, and stabilization. So the quotations out of there is AASHTO M288 Class 1 strength requirements. So there's a table that I'm going to show on the next slide that goes into the specifics of those particular requirements. And then also we had a requirement there for a minimum permeativity value being 1 sec to the -1. So I'll kind of talk about that a little bit more in the next couple slides. And then our next geotextile fabric that we spec'd out was for geotextile fabric for subsurface drainage and separation. And this fabric could be an AASHTO M288 Class 1 or Class 2 strength requirements. A Class 1 is a Class 2 just because the strength for it is higher, and I'll show that in the next slide. And then again, requiring that minimum permeativity value being 1 sec. And again, I'll get into the specifics of why we spec that out. So this is the table for geotextile class, the strength requirement that's in AASHTO M288. So they spec out in the 2015 version, they spec'd out 3 different classes. Class 1 being the fabric that is most resistant to puncturing or tearing. And so you can see that's reflected in the grab strength, the different test methods that they do. As your strength goes up in those, your numbers go up. So your grab strength that requires more strength to be applied to that fabric to tear it or puncture it with those different types of fabrics there. So in our specs that we spec'd out, we're either going to have a Class 1 or a Class 2 there based on the different applications that I previously talked about in the previous slide. So that ends up with getting into the next goal that we had for updating was reducing the number of geotextile fabrics specified in general applications. So with this one, Class 1 and Class 2, we are only going to have 2 bid items for geotextile fabric, and you can see what they'll look like there. So we'll either have a geotextile fabric Class 1 or a geotextile Class 2. And then getting into the next requirement that was in there was the 1 sec permeativity value that was required. The reason for this is that permeativity value is very high for fabrics. And so that's going to allow for water to flow freely through the fabric. And also what it leads to is that typically only non-wovens will have that high permeativity value. So it kind of narrows down to even more the type of fabrics that we're going to be laying down. And on top of that, non-wovens, there's a property called apparent opening size, and so that quantifies how big the pores are in the fabric itself. So the bigger the pores are, the bigger the apparent opening size is, the easier it allows particles to go through the fabric and get to the other side of the barrier there. And so with the non-wovens, generally the apparent opening size is very small, and so those fabrics are good for soils with greater than 50% fines for separating. And so with a non-woven geotextile, you can it's good to use those when you have soils that have fines of 50% or greater, which typically throughout Kentucky you're going to run into those types of soils. Low plasticity clays or silts is generally prevalent throughout the state. And also the non-wovens also apply for more granular materials too as well. And so they kind of matches the general requirements. You want water to flow through and you want it to keep the soils. and you want it to be barrier between where the soil is trying to move through the fabric. The third requirement we're trying to hit with the update was to align our Geotextile Fabric jargon to the national jargon. So typically from our previous spec from 2012, we were using the term type 1, type 2, type 3, type 4. And sometimes I got into a little bit of confusion between people that were used to our KYTC spec and then also people that the manufacturers and people looking to find those fabrics from manufacturers or suppliers. Because what they were using is the AASHTO M288 terms, class 1 and 2, 3, or an ounce weight for those fabrics. And so we were better trying to align our terms we were using to the national standard and also what people were, manufacturers were using. And so now from here on out, we're going to try to use the terms class that are better defined nationally, based on AASHTO M288. So one thing that wasn't addressed specifically in our 2019 specification update for geotextile fabrics was type 5. So we're not going to be addressing geotextile fabrics used for high strength applications. That's ground enhancement with the spec update, with the previous spec update we did. And the reason being that for this is that we typically want, if we're trying to shoot for a particular improvement and in a particular situation, we want to kind of more analyze it on an engineering level. So kind of get an idea of the stresses that fabric's going to be put under. And so we're going to try to address any of these applications that'll need a high strength fabric for ground enhancement by project specific special notes and plan call outs. The division of materials with the update to AASHTO M288, and I think it's the 2017 version, they do define a class 1A, which has survivability requirements that is above the class one requirements. And so that kind of gets into the same type of thing we were trying to shoot for with the type 5. And so what our division of materials has done is they have already approved a listing for class 1A materials based on the AASHTO M288 requirements. But if a class 1A is called out, it'll be by a special note or plan call outs. You can kind of look to. So we have that bid item as well, is geotextile class 1A fabrics. And with class 1A type fabrics, in those applications, because we don't have that high permeativity value that's limiting us to the non-woven material, those can be a woven material, and probably will be, because your wovens typically have are a little more applicable to ground enhancement applications. With the specification update, we did have some lingering references to the old types for the fabrics. And so there are some conflicts between section 843 and the 2019 spec and some other sections, specifically 2014 or 214, 215, 603, 716, and 834. And so we are under the process of currently doing some revisions for those. And so hopefully we have a list of some of the different applications that there could be some conflict. And so I'll just kind of go through those so that way it's a little more specific on what type of fabric you would need to replace the references for. So for instance, if you're using a stabilization for pavement subgrade, it'd be a class 1 or class 2, depending on if you're using quarry rock or roadway excavation. Excuse me. Also, if you're using a fabric underneath a slope protection, that would be a class 1. So previously it would have been a type 1. Getting into fabrics used for to protect granular materials, that would be a class 2 for separation. Previously a type 4, and then fabric used to provide a filter barrier as part of a drainage system. Again, that'd be a class 2 as well. And that replaces our type 4 or our type 2. So in summary, we did our specification update for 843 to hopefully better align with the AASHTO M288 and the national standards that people were manufacturing for. The general applications for fabric, you're going to be either specifying or using a class 1 or a class 2 non-woven geotextiles based on the way our spec is wrote. And if you're needing a high strength application or a ground enhancement, and you're wanting to do that by Geotextile Fabric, then you'll be looking at a class 1A from our materials approved list. And then those will be addressed on a project specific basis. So that's what I have. Does anybody have any questions? Doesn't look like there's any questions. If that's the case, then I can put out one more poll that I had at the end. Can I get people's general responses on this one then? So which COVID rules do you still want to enforce after COVID? My wife assumed, since I was talking mostly to engineers, that would be if there are more than 10 people, I can't come. So that's what she pitched out as the most votes.
It looks like you do have a couple questions.
Oh, okay. Let's see. Oh, they're in the questions here. That would make sense, wouldn't it? I was looking for them in the chat.
I just clicked on it.
So one was from B. Swagger. Please define ground enhancements. So more or less when I'm talking about ground enhancements is I'm specifically talking about when we're looking for a fabric to be able to support some sort of load. So if you have a soil underneath that is really soft, has a really low CBR, and you're looking for your fabric to support some of the load that's coming from your pavement up top. So that does overlap a little bit with the GeoGrids applications, but GeoGrids kind of, we have spec'd out a different one. And it's talking about, what about class 2 for pipe? Let's see here. Based on the way it is, the way the spec's written out, if a geotextile fabric is used, the lowest class that can be used is class 2. So that I'm not specifically sure on how the spec is wrote for pipe, but in general, what the intent was is to use a class 2 or better. So that should be a class 2 for pipe. From Justin Henna, will the unit price for the geotextile fabrics still intended for use on pipe be set at $2? I'm not sure on that one. I'd have to follow up with someone else.
Are the PowerPoints going to be available?
I know the videos will be. I assume the PowerPoints will be as well. But
no. Oh, that was fast.
I don't know if Adam's on here or not, so I don't know what I should say on that one.
Well, hold on, let me check real quick. Nope, not in here.
Yes, I do miss him.
Yeah. No, Adam's a good guy.
Mm-hmm.
You pavement design guys are real lucky.
Okay. Well, I guess that's wraps up our presentation then, JC.
All right.
Cool.
Still got about 6 minutes if you want to do your song and dance. Final entertainment.
I mean, I can get my whistle out if you want to, but no, that's really necessary.
Yeah. Yeah, they told us how to get started. They didn't really tell us what to do. So don't log out earlier. You won't get your PDHs.
Well, if that's the case, thanks everyone for attending. So I'm going to log off here. So.
All right, looks like there's some more chat. Let's see. Oh, you all are all welcome. Let's see, staring at a bit about traffic for hours. That's funny. Jason, our new director, we don't know. If you all are not aware, I guess the structural design, the division is going to, Bart Asher was our director. He retired about a week and a half ago. So don't know who the new director is. Maybe Jason Watson. I don't know. And just to sign off here, if you all do have any questions, again, you can find us in the global or just our information, I guess, is over there. Just send us an email. Really, at any time, we'll respond to anything. Just let us know. We'll help out how we can. Anyway, I appreciate it. Enjoy the rest of the day.